Right. I hope you are audible to me. Right. This is our PTA question paper. Rod of length L and uniform cross-sectional area has varying thermal conductivity, which changes linearly from 2K at A. You imagine a rod with the left end at A, right end at B. The thermal conductivity at A is 2K and the thermal conductivity at B is K. The ends A and B of the rod are maintained at constant temperature. Now this end is maintained at temperature 100 degrees centigrade and this end is maintained at 0 degrees centigrade. Steady state. Now see, the issue here is K is a variable quantity, not a fixed quantity. So, I am hearing some disturbance. Any issues? I'm hearing some voices. K is equal to 2K minus K by L times X. That is the K. Taking X is equal to 0 here and X is equal to L here. Right. See, whatever it is, dq by dt is a constant. Ka dt by dx is a constant. You are asking dt by dx is some constant by k. So dt sorry, is equal to dx by 2 minus x by L times k. Some constant. Entire thing we will make it some constant phi. Phi is some constant. Now you apply limits. X is equal to 0, temperature is 100. At some point T temperature is. At some point see temperature is this. So T minus 100 is minus 1 by L log E 2 minus x by L by 2 minus 0. Yeah, this is T is 100 minus L log E 1 minus x by 2L. Some function like that, constant is also there. Fine. That is how your function is. Obviously, these are not the graphs for this. Also, from this, you can say slope is undoubtedly negative, and as x increases, slope decreases. So, this is the graph. First question can be done. Next. Actually, this is a repeated question. A lot of times this question got repeated, and only thing we made a big focus on screw gauge and vernier calipers, if I am not mistaken. See, one question. This is also on the same. Two questions. Three questions. 3 questions came from the same area, which means you can manage. Now here you see, when a piece of wire is held diametrically in a screw gauge, pitch is equal to 1 mm. Least count of screw gauge is 0.01 mm. Right. From the screw gauge, error is positive. Undoubtedly, when you have 20 here means 0 will be somewhere here. So therefore, this is positive error. Error is equal to plus 20 mm plus 0.20 mm, because you'll multiply that with the least count. Plus 0.20 mm error. So when you are seeing here, pitch is 1, each division is 1 here. 1, 2, 3. Right. So what is that? The value that you can see here is 3. If we measure the same with the help of an antenna, but ముందర కన్ఫర్మ్ చేసుకోవాల్సింది స్క్రూ గేజ్ సంగతి చూసుకోండి. పిచ్ 1 mm అంటే 0, 1, 2, 3 and 3 mm plus 50 into least count plus correction. Correction is minus 20 into least count. So overall that reading is 3.30 mm or 0.33 centimeters. Now the question is, which vernier calipers is the best for this? Obviously, the least count, I'll change the color, the least count of the instrument, a regular one only, 1 MSD minus 1 vernier scale division. So this will become 1/10 of a main scale division. One main scale division is 1 mm. So this will be 0.1 mm, the least count of the instrument. Right. It is having a negative zero error of plus 0.5 mm. Now actually, very simple. I'll equate 0.33 is equal to reading plus vernier coincidence into least count plus correction. Hold on. 0.33 is equal to reading plus vernier coincidence into least count plus what is correction? It is having a negative error of 0.5 mm. Means you need to convert this into centimeters actually. That can be written as this is 3.3 mm or 0.33 centimeter. 3.3 mm or 0.33 centimeter. Right. What is this? This is 0.5 mm. And that too plus error, zero negative errors or positive. So therefore, what should be the correct option here? It must show 0.33 minus 0.05 is equal to 0.28 centimeter. Somewhere here this should show. So now 0.28 centimeters means the zero of the vernier should be somewhere between 2 and 3. Search for that option first. Of course, this is between 2 and 3. 2, 3. This is also between 2 and 3. Okay. No. Area 0 is between 3 and 4. Wrong. Here also 0 is between 3 and 4. Wrong. So 0 of the vernier is on 2. Wrong. So without verifying anything else, you can confidently say this is the answer. Otherwise also I'll try to show you. The 0 of the vernier lies between 2 to 3. Fine. Which is the best coincidence here? The problem is you should be very clear in the exam part 7. 7th division. So therefore, 7th division. So reading plus vernier coincidence into least count must be 0.28. So obviously the coincidence is somewhere around, what is that? I took it as 0.2. This should be 0.20 and this should be 8 into 0.01. Only then you will get 0.28. Okay. So in this, unless or until you are the major skill of my selection of the option is eliminations. I eliminated 3 in this. Next, 22. Students of 4 classes measure the height of the building. Each class uses a different method and each measures the height many times. Number of times measuring. And they are measuring. Class A, for example, measures some A method, B follows B method, C follows C method, D follows D method. They're asking about precise measurement. So how close one reading is to other? Like for example, in NCERT, you had an example problem. 1 clock shows the correct time is 10 o'clock. 1 clock shows 10.05, 10.10, 9.55, 9.50, 10.10, likewise, different readings. 1 clock shows like this. The other clock shows like this. This is in NCERT actually. 12.01, 12.00, 11.59, 12.01, 12.00. You see, all the readings are wrong actually. They are far from the accurate value, but their measurement is close. Such a thing is called precision. So out of the 4 options, see, the height is close to 30 and majority of the students measured the height close to 30. Whether 30 is correct or not, that's a different story. Majority of the students measure. See, I don't see any precision in these 2 observations. I see precisions in these 2 observations. But out of these 2, more precise is this one. So what is the meaning for precision? How close the measurements are. The measurements are. How close the measurements are is what we call about precision. Right. Next, 23. A copper sphere is suspended in a vacuated chamber maintained at 300 Kelvin. The chamber is at 300 Kelvin. The sphere is maintained at a constant temperature of 500 Kelvin by heating it electrically. A total of 300 watt electric power is needed to do it. When half of the surface of the copper sphere is completely blackened, right? 600 watt is needed to maintain the same temperature of the sphere. See, don't get confused. If it is completely black, 300 watt of electric power is needed to do it. When half of the surface of the copper sphere is completely blackened, 600 watt is needed to maintain the same temperature of the sphere. Now, what is actually happening? Drum question. It is like a drum question. I told you a number of times. What is a drum here? You are giving heat. The body maintains some temperature. Besides, it radiates. So, once the level is constant, means the inflow is the same as the outflow. Right. So, the power input is same as the power radiated. In the first case, 300 watt is equal to sigma, I'm assuming it as a black body, into area into 500 power 4 minus 300 power 4. This is the rate of radiation. This is the rate at which it is taking in. Now 600 watt is equal to sigma into 1 into A by 2 into 500 power 4 minus 300 power 4 plus sigma into half is emissivity, E, because 1/2 is not black. 500 power 4 minus 300 power 4. You have now two equations. Equation 1, equation 2. Go for ratio. Left side you will get 1 by 2. Right side you will get sigma A by 2 plus sigma EA by 2. You can even cancel sigma A. This will become 2 by 1 plus E. So therefore 1 plus E is 4. I think 1 minute. Sigma A by 2, sigma EA by 2. Correct? 1 plus E is equal to 4. E must be less than 1 actually. Let me see that if I have done any. Initially the emissivity is E. Initially the emissivity is E. E. 2E. So therefore 4E. E is 1 by 3. That's all. Initially, full is emissivity E. Secondly, half E, half black surface will have emissivity 1. A very easy question. Even there is no difficult calculation involved in this. Right. Next, 24, 25. Now, in this, carefully observe, the slopes will give some information. A 0.60 kg sample of water and a sample of ice are placed in two compartments A and B that are separated by a conducting wall in a thermally insulated container. The rate of heat transfer from the water to ice through the conducting wall is a constant, and that is P, until thermal equilibrium is reached. Right. Until thermal equilibrium. Here the thermal equilibrium part is 0 degrees centigrade. Right. The temperature T of the liquid, water and ice are given in a graph form as shown. Right. Specific heat of the ice given. Specific heat of water given. Right. Now, may I ask a question, please, here? No. What is plotted in along Y? It is plotted temperature part. Now, P is M ice, specific heat of ice, dt by dt. That's the deal. And you can see that here ice 0 minus 30. This part is minus 30 for ice. So M ice, specific heat of ice, dt by dt. This slope part is 30 by 60. 30 by 60, that to minute. So it is 30 by 60 times 60. Now it is in seconds. That is the power. So specific heat of ice, they have given 2000. Okay, what about water? Water is losing actually heat. M water, S water, dt by dt. This is ice. This is water. M water, S water. What about water? Can you please help me? 40 and 40. 40 by 40 times 60. Right. That's the picture. Now, 0.6 kg sample of water and a sample of ice. Right. And one more important point is, here also there is a transfer of heat for 20 minutes. So how to calculate that? In that 20 minutes, what is happening? In that 20 minutes, ml is happening. In fact, ice. Okay. And you calculate the power here, somewhere here. Power. They have given this as 0.6. Water mass is 0.6. Yes, water 4200 into yeah, it is like 40 by 40, 10 by 10, 600. So now carefully calculate. All this becomes 42 watt. Now in this case, 42 watt is a constant power. 20 minutes. 20 into 60. By solving which you will get M. M is in fact 42 into 20 into 60 by M is L is. L is 3.3 into 10 to the power of 5. Arey bhaiya, this 42. In the entire part, the toughest part is the calculation. The toughest part is the calculation. Else, this is fine. 42 into 12 by 3.3 into 10 to the power of -3. That's the deal. So, yes, you cannot even estimate, because this is, for example, 42 into 12 by 33. You can write it as 10 power -2. Rough calculation, nearly 3 times. 3 means 16 times. So it should be close to 16. 16 into 10 power -2. But you should do calculation part carefully, else you will find it problem. Right. This can be done. But the problem with this is 2 marks. Suppose if you are good here, if you find time taking in this part, leave that and go for the next question. Rest. 26 and 27. Right. In a certain system of absolute units, acceleration produced by gravity in a freely falling body is denoted by 5 in that units. Kinetic energy of a 500 kg shot moving with velocity 40 meter per second is denoted by 200 in new units. and its momentum by 100 in the new units. Right. See, please try to understand where we have G, there you can use 5. And where we have 500 into 400 square by 2, there they have 2000. Okay, hold on. I'll just mark this in a different way. If you are not mistaken, this is kg meter square per second square unit, and this is some 2000 in the new units, right? Which means new units of mass m1 L1 square by T1 square, right? And also I need to write our G 10 times L by meter square by 10 times meter by second square can be written as 5 times length by T1 square, right? Two terms we have. And it's a momentum. Momentum means, say, 500 into 400 kg meter per second in their units is 100 m1 L1 by T1, right? That is the information. You have 3 unknowns, 3 equations. Just solve it. Now, see, for example, you have equation 1, you have equation 2. Okay, what if you permit me, what I can do is, if you permit me, I'll take equation 2 by equation 1. Here I will get 500 into 400 square by 2 divided by 500 into 400. In return, I will get a meter per second. So here what I will get, 2000 by 100 meter per second. So L1 by T1. Good. So what I will, let this be equation 4. Let this be equation 1. Let this be equation 1. What if I do equation 1 by equation 4? 10 times meter per second square by, you complete this calculation. This will be 200. 200 times meter per second is equal to 20 times 20 times equation 1 by equation 4 actually. Equation 1 by equation 4. Equation 1, 5 times L1 by T1 square by 20 times L1 by T1. That's what I got. Finally, this will become 1 by 20 times 1 by second is equal to 1 by 4 times 1 by T1. Implies T1 is 5 seconds. Done. Use this T1 in any of the equation here. You want length, no? Use this any of the equation. Even you can use this in the very first equation actually. 10 times meter per second square is 5 times L1 by T1 square. 5 square second square. The L1 is 50 meter. Done. Easy question, which you should not miss, actually. I am not expecting that any student have done mistake in this question. This is like a full toss slow ball. Next, 28, 29. Don't worry about the length of the question all the time. A block is kept in a room which is at 20 degrees centigrade. To raise the temperature of the block, heat is to be given at a constant rate of 600 watt using an electric heater. The temperature of the block rises with the time as shown in the figure. You can see that some graphical arrangement is given for you. The slope of the graph at t is equal to 0 is 3 degrees centigrade per second. Once the temperature rises to 60 degrees centigrade, the heater is switched off. Heater is switched off. And then another heater is switched on to maintain the temperature of the block at 60 degrees centigrade. This new heater supplies heat at a constant rate of 100 watt. Right. If the new heater is switched off, assuming that the rate of heat loss by the block to the surrounding is proportional to difference in its temperature with surroundings, the net heat, this is a lengthy question, but solution is simple. Let me study the question and let me post the answer. At 60 degrees centigrade, initially, what is happening? They have given some 3 degrees centigrade per second. I need to understand what is happening initially. Initially, block temperature is equal to surroundings temperature. So therefore, radiation loss is 0. So whatever the heat is given, that is used for the rising temperature of the material. So heat capacity, I think you uttered somewhere. MS. This is called heat capacity. dT by dt. You said initially you are giving 600 watt. 600 is MS. 3 is the slope. You said slope. D. This is the slope initially. dt by dt at t is equal to 0. That you have given as 3. Right. Now, yes. So now the question is, what use MS? MS in this case is 200 joule per degree centigrade. Done. The first part of the question is easy. Now you go for the second part of the question. At 60 degrees centigrade, block is, you said the new heater supplies heat at 100 watt. Via drum question again. In the drum question, you are giving 100 watt heat, still the temperature remains constant. How is this possible? The rate at which radiation takes place is the same rate at which heat is given into the system. So therefore, 100 watt is equal to some constant times. You said, you have a minute. The surrounding is at 20 degrees centigrade. Once the block reaches 60 degrees centigrade. So you said this 60 minus 20 is the rate at which it is lost. Next. So I know the constant right now. The constant value K is 100 by 40. 10 by 4, 2.5, wherever it is required, I will use, right? At 30 degrees centigrade, to maintain temperature in the same condition means radiation loss is the power input, which means 2.5 into 10 is the power input. So therefore, in this case, this is 25 watt, 25, right? See, the net heat lost per second by the block when it was at 30 degrees centigrade is, at 30 degrees centigrade, the rate of loss is K into, you said in the question itself, Actually, Stefan's law, T power 4 minus T naught power 4. In the question itself, assuming that the rate of heat loss by the block to the surrounding is proportional to difference in its temperature with the surroundings. In fact, I've used that. So numericals, out of my favorite numerical undoubtedly is this one. Easy. A bit difficult. Second part calculation. This is also a bit easy. If you identify drum situation here, you can manage. Next, question number 30. The length of the string of a simple pendulum is measured with a meter scale to be 63.4 centimeters. The radius of the bob plus the size of the hook is measured with the help of vernier calipers to be 1.56 centimeters. Select the correct statement. Yes, this is the most easy question. At least two you can opt. Least count of the scale, correct? 0.1. Least count of the vernier calipers, 0.01. Effective length of the pendulum, 63.4 plus uh, half of, no, effective length of the pendulum. The radius of the bob, not the diameter here. The radius of the bob plus the size of the hook. If this is the hook, this is the string, this is the center of mass of the bob. This is called L effective. And that is nothing but the length of the string, 63.4 plus 1.56. 1.56 centimeters, 63.4. Okay, now if you take the sum, only see A you will do correct, B you will do correct. You may leave C because you will feel that the answer is. Remember, significant figures works here. In the process of addition, decimal followed by only single term, only one place. Your answer must contain one place. So therefore, you need to eliminate or you need to round off this to have this to one single. 64.96 round off 6. So then it will become, raise the number by 1, 65.0. So here you should follow significant figure rule to express answer. Right. To express the answer. Right. Next, 31. A vessel of negligible heat capacity is having a volume V0 of water at temperature T0 from a what is this? Faucet above. From the facts of above, I need to get some conclusion on this. Okay, I'll read the further question. Water is falling from a geyser at a constant rate or volume flow rate. The temperature of water from the geyser is 3 T naught. Then the correct statements is or are. Assume immediate mixing of hot and cold water. In time T, say in time T, okay? In time T, mass of water fallen into vessel. Mass of water fallen into vessel is, here you rate volume rate, density or T at a temperature 3 T naught. So therefore, you said the vessel of negligible heat capacity is having V naught volume of the water at temperature T naught. So heat lost is heat gained according to principle of calorimetry. Heat lost. Who is losing heat here? Rho mass 3T naught minus equilibrium temperature into S is the other side rho V naught mass T minus T naught. Yes. Cancel S, cancel rho. So finally, you have 3T naught minus T is V naught by RT times T minus T naught. So therefore, T is equal to 1 plus 2RT by V naught plus RT times T naught. Right. That is one equation I got. Of course, temperature of the water in the vessel increases, but not linearly. Suppose it denominator is not containing the time term, it's a linear. But denominator is also containing time term, so it is non-linear. The volume of the water in the vessel becomes 2V naught when the temperature is 2T naught. Now, the question is, I'll go in a reverse sense now. What if I place in the place of T 2T naught? I'll get the condition 2 is equal to 1 plus 2RT by V naught plus RT. So V naught plus RT is 2RT. So RT is V naught. So T is V naught by R. Okay. The volume of the water in the vessel becomes 2V naught when the temperature 2T naught. Now this is the time. So what is the volume in the container? Already existing V naught fallen RT. So RT is V naught. So totally this will become 2V naught. This will become 2V naught. Under which conditions? Under this condition. The temperature of the water is 5T naught by 3. Put T is equal to 5T naught by 3. You will get the same. Do the same process. You will get small t as the answer. Right. So 31. See, remember how many questions I have done now? 1, 2, 3. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In what time? Hardly in a time less than an hour. It's a comfortable paper for you. In fact, my system shows a time of 43 minutes run time till now. My Zoom time. So within 43 minutes, we can answer this much number of questions. Next, a thin copper tube perfectly conducting of outer radius 0.5 centimeters carries a liquid flowing at constant temperature T is equal to 100 degrees centigrade. The copper tube loses heat according to Newton's law with constant of K times T minus T naught. Right. The temperature of the surroundings also given. Now we coat a layer with thermal conductivity so and so, K given, thickness given. Assume the outer surface of the layer loses heat with the same constant of proportionality. Right. Wow. Carries a liquid flowing at constant temperature 100 degrees centigrade. The tube loses heat according to Newton's law with a constant of proportionality. The temperature of surroundings is 20 degrees centigrade. Okay. Now, okay, fine. dq by dt to surroundings is some k times T minus T naught. You know this. The K is given as 3 into 10 to the power of minus 3 into see surface area 3 into 10 power minus 3 into surface area 2 pi r L 2 pi outer radius 0.5 you said 0.5 into length is. Now why you asked me to write this, I'll explain. This term includes per unit area. See, the constant of proportionality contains per unit area term, but overall this much area you are radiating. So that should be written in the temperature difference is 80. That is the initial equation. Right. Now the same rate you want 10 power minus 3 pi into L into 80 is equal to, let us say this one as K1. Now K A 100 minus T. No, you know the resistance part. For a concept, for this arrangement, you know the, suppose if the inner radius is R1, the outer radius is R2, we know the expression for the resistance. What is the expression for the resistance? 2 pi KL by natural logarithm of R2 by R1 is R effective, thermal resistance. That you write over here. This is current, rate of flow. Current is equal to temperature difference. What is the temperature difference? 100 inside, outer surface T times denominator resistance, R effective. 100 minus T times 2 pi KL by log E R2 by R1. That we have. Now I am equating both by doing which you have pi cancel, L cancel, K also they have given. See, basically by doing all the calculation, you will get the temperature term as 460 by 7, which is the same as 65.7 degrees centigrade. That's the temperature. The temp, right, 1 point I got. Right. What about the rate of loss of heat? Now the dH dash by dt by previous dH by dt we will compare. This is 3 into 10 power minus 3 into L into 460 by 7 minus surrounding temperature 20 into 2 pi by dH by dt initial part. So by substituting which you get, you need to do a place constraint is there. Now you just compare the initial rate of radiation and the final rate of radiation. That gives you the answer. Now don't get confused. Only difference is the surface now emissivity కూడా ఇచ్చినట్టున్నారు మీకు. No emissivity. They should give emissivity also. They should give emissivity also. If not, we should take this as a black body. Now, the only issue is that it is proportional to 460. 1 minute. See, this is also a different term. అంటే న్యూటన్స్ లాలో dq by dt is some constant times T minus T surroundings kada. E K different now. So 460 by 7 minus T times K, new K, 2.8 into 10 power minus 3 into area by next part, initial part 3 into ఇదే కాపీ 10 power minus 3 into 2 pi into అరే ఎల్ ఏ కామన్ ఇయర్ into area part L part తీసేసాయి into 80 by solving which you will get the answer as 8/7. But it's a lengthy question practically. You need to have some idea about every step of this question. 33. Already I taught you solar constant, same question. The temperature of the earth is maintained by a dynamic equilibrium between sun and earth, which means energy received from sun and energy radiated by the earth is the same. So the temperature of the earth is maintained constant. Right. Now you already know the power emitted from the surface of the sun is sigma 4 pi r sun square times T sun to the power of 4. If the radius of the sun doubles without changing its power, so what happens? R sun into T sun to the power of 4 is T sun power 2 is a constant now. Now what happens? T sun is proportional to 1 by R sun. Proportional to, you have doubled the radius. 1 by root 2. Correct. If the power output of sun would double with the changing, if the power output of the sun would double without, I think, it is without changing the temperature, equilibrium temperature of the earth also doubles. Wrong, because P sun is proportional to T earth power 4. So therefore, that is a different. So wrong. So therefore, next part, C. If the radius of the earth doubles without any change in sun, and E part, no change. Then what happens? Its equilibrium temperature would increase by a factor of root 2. Wrong. You said that this part is constant. Anyway, these two gets cancelled. TE still depends on this fraction, which is a constant. Nothing happens. If the distance between the earth and sun would become half of the original value, the equilibrium temperature of the earth would increase. Yes. Now TE power 4 is proportional to 1 by R naught square. So TE proportional to 1 by root R naught. So obviously, if this is the distance between, this is halved. So TE becomes root 2 times of the previous value. D correct. Out of all multiple correct answer, this is most comfortable, least calculation. In fact, you have calculation here, undoubtedly. You may do only 2 correct justifications. But whereas here, perfect clean hit question. You cannot go mistake in this, right? Provided if you know how to read English, right? 34. I told you there is one question in previous IIT questions. I marked that also. Same concept. A human body is a remarkable device that maintains the temperature of its surface at 37 degrees centigrade, irrespective of the external temperature. A man whose surface area is 1 meter square is standing naked in a room at temperature 7 degrees centigrade. The man can wear a fur coat of almost the same external area, same emissivity, thickness 1 centimeter, thermal conductivity so and so. The body loses heat to the surroundings or to the fur coat at a rate given by so and so. It is same as cut, copy, paste of this question. If you are good at 32, you'll be good at 34. Right. So let me do this question. Okay. Right. Body temperature is 37.T1 and you said 2.5A some number. 2.5A into 37 minus 31 is what radiated by the body? Our skin, by skin. And this is conducted. Ka by L, L stands for the thickness of the fur, T1 minus T2. Again, from the area skin, fur, air. Earlier, skin is directly radiating to air. Now, skin radiates, and because of which the inner surface of the fur will have T1 temperature, the outer will have T2 temperature, and air will have 7 degrees centigrade. The inner body will have 37 degrees centigrade. So that's the picture what you have. Now, you have different equations again. So, here, actually speaking, you solve this, you'll get from these two substitutions. By solving these equations properly, you will get the value of T1 as 25 degrees centigrade and T2 as 19 degrees centigrade. Right. Right, fine. That's not the question, sir, now. The rate of heat lost by the man without fur coat is, without fur coat, it is simply 2.5 into 1 into 37 minus 7 degrees, 37 minus 7. So 30 into 2.5, 75 watt, correct. The rate of heat lost by the man with fur coat is 2.5 into 1 into 37 minus 25. What is this? Nearly 12. 12 into 2.5, 30 watt, correct. With fur coat, the temperature of the outer surface of the fur coat already I have derived 19 degrees. When ABC are correct, D is wrong. See, I am repeating again. If you are good at 30-second question, you will definitely do 34th question. Try to please remember 35th question I have done in the class. A black body and a silver polished body of same heat capacity and of same geometry are taken out from a cool environment and kept in sunlight. They are isolated from each other. Now choose the correct statement. See, silver polished will have less absorption. Black body will have a very good absorption. Good absorbers are good radiators. So temperature of the black body will increase faster than silver body is correct. The final temperature of both will be same after a long time, right? Because after a long time, both should maintain equilibrium with the surrounding temperature, ambient temperature. Maybe black body will reaches quickly to ambient temperature. Silver surface will slowly reach to the ambient temperature. That's all. I taught this question in the class. Similar model. Right. 35 is a clean hit, easy question. Next, 36. A copper calorimeter has a mass of 180 grams and contains 450 grams of water and 50 grams of ice, all at 0 degrees centigrade. Dye stream is passed into the calorimeter until a certain temperature theta is reached. Right. The mass of the calorimeter and its contents at the end of the experiment increases by 25 grams because of condensation of water. 25 grams refers to condensation, maybe, right? Assume no heat loss to the surroundings, take specific heat capacities of water, copper, etc. take specific heat, take specific latent heat of fusion of water given or your final temperature, right? You have 180 grams calorimeter, 450 grams water in it, and 50 grams of ice in it. Wow. So you pass a dry stream into the calorimeter until a certain temperature theta. Very clear with this information, there is condensation. So equilibrium temperature is no longer 100, maybe below 100. Let me just check. What is happening over here? 50 grams of ice need to melt 50 into 10 power minus earlier. See, the question is all are known terms for us. Use everything in calories, no issues. 50 into 80 plus. They have given this in joules here. Okay, right? 50 grams, 50 into 10 power minus 3 into ice fusion is 3.36 into 10 power 5 plus 180 copper calorimeter into specific heat capacities of water and copper to be 180 grams into copper 390 into theta minus 0 plus 450 into 10 power minus 3 is also there. 450 into 10 power minus 3 into that will be 4200 into theta minus 0. Remember, the entire term is heat lost, heat gained. Now we'll check with heat lost. Heat lost, you said 25 grams extra into state loss. And vaporization is 2.26 into 10 power 6 plus 25 into 4002 into 10 power minus 3 into 4200 into 100 minus theta. Except theta, rest all data you know. So just solve it, you will get answer. You will get the answer for this theta as 22 degrees. You will get the answer as 22 degrees centigrade theta, solving which. Now you said the final temperature is 2x, means x is 11 degrees centigrade. You want x minus 4, 11 minus 4, 7 degrees centigrade. That's all. That's all. Okay, right. Next. 37. The main scale of a vernier calipers reads in millimeter and its vernier is divided into 10 divisions, which coincides with 9 divisions of the main scale. The reading for shown situation is found to be 23x by 10. Find the value of x. Very simple device. Now, okay, least count is a regular thing. Least count is 1 MSD minus 1 vernier scale division. So this is simply 1/10 of a main scale division. It is 1 mm. So 0.1 mm. Right. See, zero error if you see which division is coinciding. 1, 2, 3, 4, 5, sixth division is coinciding. When sixth division is coinciding, I told you one point. When sixth division is, and 5 can ఎక్కువ ఉండకూడదు, అప్పుడు 1 minus 6 you take it as a correction. 1 minus 6, 4, right? The reading for the shown situation is found to be ఇదేంటి 0, 1, 2, 3, 4, 5, 6 plus coincidence, this one, 1, 2, 3, 4, fifth division into least count. Least count is, this is 6 mm plus 5 times, it is the least count, 0.1 mm plus correction. That's what you need to have here, plus correction. Okay, 6.9 6.9 mm. This can be written as 69 by 10 mm. This can be written as 3 times 23 by 10 mm. 3 is the answer. Easy. Only thing that you should not be betrayed is this part. I told you very clearly, it can't, negative error, coincidence can't be more than 5. In such a situation, if it is more than 5, you should take 1 minus of that as the correction. Right. Right. Next. Maybe last. Mr. Vivek Taparia performed an experiment to verify Ohm's law. He connected following circuit to measure the voltage and the current, where R is the known resistance, V the voltmeter, A the ammeter, and K is the key. The value R from the following readings is given by so and so. Find alpha plus beta. Our voltage by current is resistance. I have determined 4 cases. See, you want to express it in this terminology. So therefore, I have expressed that rounded off 7 into 10 power minus 1 kilo ohm, 7 into 10 power minus 1 kilo ohm, 5 into 10 power minus 1 kilo ohm, 6 into 10 power minus, I'm just rounding off. 6 into 10 power minus 1 kilo. Average is 6. 6. Remember, I got 6.2 actually. But again, you want to express this in one single term. So 6 into 10. Very simple, yaar. Don't question me like that. See, voltage is having one single term. So your final answer must have one significant figure. So therefore, 6 into 10 power minus 1 kilo ohm. Alpha plus beta. 6 plus minus 1, 5. That is the answer. So it took 1 hour, 8 minutes run time here. Actually, some 5 minutes, 1 or 2 minutes, you can